Good morning, students. Today I'm going to show you how to solve numericals based on Boyle's law. The other day you studied what is Boyle's law, what is Boyle's law equation. P1 V1 equals to P2 V2. Now let's say you are given a numerical based on Boyle's law. At a particular temperature, a certain quantity of gas occupies a volume of 74 centimeter cube at a pressure of 760 millimeter. If the pressure is decreased to 740 millimeter, what will be the volume of the gas at the same temperature? Now, since the temperature in this particular numerical is constant because it is same temperature throughout, so I know that the numerical is based on Boyle's law. So I'm going to use Boyle's law equation. So I would advise you to read the question once, twice, or thrice. Jot down the information that is provided to you in the question, maybe the initial pressure, initial volume, or final pressure, final volume. What is being asked? Put a question mark and solve by using the equation P1 V1 equals to P2 V2. Now let us solve the numerical. According to the question, initial pressure is 760 millimeter of mercury. So P1. V1 is the initial volume, and the initial volume occupied by the gas is 74 centimeter cube. If the pressure is decreased to 740 millimeter, so the final pressure P2 is how much? 740 mm of mercury. What will be the volume? So you are supposed to calculate the final volume V2. Are you with me? So by Boyle's law, P1 V1 equals to P2 V2. Initial pressure into initial volume is always equal to final pressure into final volume. When I substitute 760 into 74 gives you 740 into V2. What am I supposed to calculate? Final volume, that is V2. Therefore, V2 equals to 760 into 74 divided by 740. Simple unitary method. You cancel 0 with 0. Okay, 74 will go here and 74 once. So your answer is 76 centimeter cube. Therefore, the final volume of the gas is equal to 76 centimeter cube of mercury. It's a very simple and a straightforward problem, okay, and I'm sure all of you should be able to work out these types of numericals. Are you with me? Now let us move on to the next type. Read the question very carefully. At a constant temperature, volume of a gas was found to be 400 centimeter cube at a pressure of 760 millimeter of mercury. If the pressure of the gas is increased by 25%, find the new volume. Read the question once, twice, thrice. Then whatever information they have provided, jot it down. P1, V1, P2, what is V2, whatever it is. Now, look at the initial pressure. What is the initial pressure? 760 million. So I put here 760 mm of mercury. What is the initial volume? V1, which is 400 centimeter cube. Now, final pressure. According to the question, it is clearly said that the pressure of the gas is increased by 25%. In maths, you studied 25% means what? 25 upon 100 into 760. it is increased, so plus 760, right? So 25% of 760 plus 760 will give you 950 millimeter of mercury. This is the final pressure. And what you're supposed to calculate? The final volume. Again, by Boyles law, P1 V1 equals to P2 V2. Final initial pressure into initial volume equals to final pressure into final volume. So I put the values here. 760 into 400 equals to 950 into V2. Therefore, V2 equals to 760 into 400 divided by 950. When I cancel it, I get, therefore, V2 equals to 300 centimeter cube. Now, what does this V2 stand for? Therefore, the final volume of the gas is equal to 320 centimeter cube. Are you with me? So these are some numericals which are based on Boyle's law. You have to solve more numericals so that you get confidence, and I'm assuring you it's very easy if you practice. I have given you 2 more questions in your assignment. Please do it by yourself, and it's more or less like this what I have taught you today. Thank you.